There are some classes that I took where I just asked myself, like, do we really need to know this? But now you realize, like, you didn't know everything, but the principles behind them are what makes the job what it is.
A lot of opportunities to take on challenges and kind of make yourself uncomfortable in order to better yourself, to learn new things and expand your horizons.
Alrighty, greetings and welcome to yet another Sounds of Solar podcast. I'm your host today, Christoph Brun. Joining me, let's go this way.
Back again, Sheridan Henderson.
What up?
Prahlad Shankran.
Walalin on the mic.
I love that. Is that your new handle online?
Well, no, it's not. But, you know.
Yeah, could be. We're talking today about emerging engineers. Do you guys remember when you were an emerging engineer? Think back.
Yeah.
A few years ago.
Yeah.
Yeah.
It's not an easy time in life, right? To transition from college, school, whatever. Especially a lot of these folks moved to the U.S. for the first time.
Right.
Also, it's just like a lot.
For me, it was like, especially as soon as I graduated, like the most difficult thing was trying to get into industry. I knew I wanted to get into the renewable space, but I didn't know if I wanted to do like power electronics, power systems, like what do I get into? Like,
Yeah.
just because everything
How do you do it?
Yeah, how do you do it? And everything I studied so far was all theoretical. And I was like,
Right.
what if they asked me to measure the voltage? I was like, do I really know how to do that?
Yeah.
And-
Yeah.
Yeah.
But I got lucky. Like the company that I got into was a startup just based out of Philadelphia, and it was kind of a funny story. But like I packed all my bags from Philly, moved to California to try to find a job,
Yeah.
and then literally I think the minute I landed there, the two folks reached out and they're like, "Hey, can you come back to Philly for an interview?" I was like,
What?
I just moved maybe next month. They're like, "No, we need you right now." And then next week I flew back. Then interview happened, and somehow I got.
What were you doing
So-
in between time? Were you like,
He was vacationing in California.
What do you mean, like in between?
oh, so, okay, I see what you're saying. Yeah.
Like I graduated and then
Yeah.
I just had to find a job, and
Yeah.
I was just couch surfing with a friend
Okay.
in California. Yeah,
I was like, Prati is just like
just chilling in
a
Cali-
nomad now.
Nomad? No.
Yeah.
I was kind of like a nomad because I just couch surfing. But yeah, no. But that was my kind of story, and I got
What
a
were
lucky
your
break.
thoughts from this period of time of your life?
Yeah. What I remember very well is that I was at the end of schooling, man, and I just felt like I was tired of it.
Yeah, there's that.
I was fatigued and I mean, I graduated during COVID too as well. So it was just like tough time. What you just touched on, like the theory. So we had all this theory and little bit of just application, right?
Yeah.
Like experience. And I'm thinking about it and I'm like, oh, I'm self-doubting myself because, you know, like you've learned all these things.
Oh,
but
yeah.
you
There's a
don't know-
lot of imposter syndrome.
Right.
Yeah.
You're wondering, oh, am I going to be able to do what I'm supposed to be doing, right? But deep down also you have that
I
belief.
still wonder if I'm capable of doing
it never
what I'm
goes
supposed to be
away
doing.
because it never goes away because the field is too big, right? So
Yeah.
you're just learning every day. But at that moment, you're just wondering, like, you know, you have to. I leaned on if they trusted me, and I'm trusting myself
Yeah.
as well. I can do it, right? So, but I was actually traveling at that time.
Yeah.
Yeah, you know, what I did is that I applied, packed my bags, and brought one blazer
Yeah.
and a shirt, and I knew there's gonna be interviews while I'm on vacation. So I did my my interviews while I'm on vacation,
Yeah.
different time zone, and you know, like
I love that worked for you in
Yeah, I know.
2020.
That's
In
so- that's so
2012,
Wallace-
it
for
was
me, would've
so
been
it
like-
was so I graduated
No.
2020, but the interviews were 2021, beginning of
Yeah.
2021, right? So
Sure.
we were allowed to travel at that time with as long as you take
Yeah.
your tests and all
Zoom
that.
didn't even exist when I was looking for jobs.
Right.
Same here.
Back when
I
it
think
was like writing a handwritten letter.
Archaic.
Yeah, exactly. I know. That was reality.
Yeah.
just when I got used to Skype, it was no longer.
I know. Yeah, Skype is like, it's here and it's gone. So for today's show, we've got 4 emerging engineers here at EVS. They've all been here, well, not very long, a few months, really. So each one of these fantastic hosts here on the Sounds of Solar is going to take one emerging engineer, get their life story, get everything about them, get to the nuts and bolts, and hear all about what they have to say about life before and now into solar. So with that, why don't we hear what they have to say?
Welcome.
Thank you. Thank you
Yeah.
for
How
having
you
me.
feeling?
I feel great. How
Yeah,
are
you
you?
had coffee or tea?
None
That's a
of
very
the above,
important
actually.
question.
I just had water.
Water? You don't drink coffee or tea? All
Uh,
engineers they drink coffee,
I
but
don't
you
drink
don't.
coffee at all,
Okay.
and tea makes me drowsy. So
Oh, okay. It's okay. We'll get you to drinking coffee here.
yeah.
Anyways, tell me. So, you're a new engineer. You just graduated recently. Tell me more about yourself. Who is Viola?
My name is Viola, as you've already said.
Yeah.
I went to St. Cloud State University. I studied electrical engineering with a minor in mathematics.
St. Cloud State University. That's in Germany, right?
That's in St. Cloud, Minnesota.
Oh, Minnesota. Okay.
And I studied electrical engineering with a minor in mathematics, and now I'm here. I am an engineering associate 1 within the power studies department, and I've been here since the first week of August.
So, what got you to engineering? Like, why engineering? Why not
Yeah.
education?
So I kind of did an elimination process where I knew what I didn't want, and so I knocked those off. So I knew I didn't want anything in the liberal arts. I wasn't so keen on writing, especially like the essays, and I have to read all these books and analyze them. And I wasn't the biggest fan of that, but I was good at math. So I decided I would probably do something math inclined. And then it came down to, okay, well, let's look at all the majors that are math inclined. And there's mathematics itself. And I was like, no, that's too much math. And so I decided I had done some like pre-college programs, and I had gone to U.S. Space Camp, and those were fun
So
experiences.
you had love for math, but not that much love for it.
Yeah, not too
it's
much
like,
though.
you
You know,
know.
just enough math
Yeah.
for me. So I'd gone to space camp, and then I'd gone to UMass Amherst, where I had a summer pre-college program, and we went to one of the colleges for a visit. And there's this sign that said "Women in Electrical Engineering,"
Okay.
and it was so nice. And I took a picture. There was 4 of us girls, and we just took a nice picture because it was fun. And then when it's time to apply for college, it's like, well, electrical sounds fun, but I was like, it might be too much. In my head, I thought of like wires, and I was like, that's too many wires. Let's go computer, where I do some coding and then throw in, some hardware on the side.
I mean, that's a big misconception when it comes to electrical engineering.
Yeah.
We get confused with electrician. We're not electricians.
Yeah,
We
I
are
had the electrician mindset.
Yeah, okay.
And so I started off as computer engineering until junior year,
Okay.
where I felt like I just couldn't handle any more computer science classes for coding.
What class made you switch?
It was computer science 2 in
Okay.
St. Cloud. We call it CSCI 301.
Okay.
That was the breaking point for me. That
That's
was,
just too much coding.
yeah, it was just too much. And at first I thought, okay, I could just push through. But then I look at my degree audit, and there's still many more classes to go. It's like, how many of these can you possibly push through? And so I just
So let me get it. It was too much coding, and then you look at the curriculum. You saw like there was so much engineer classes yet left.
yeah, there's more coding classes.
And looking at your bank account, you're like, okay, your fund is running low, right?
Can't take an extra year,
Can take an extra
an
year.
extra 2 years.
You know, funny thing is that I had the same type of experience too, in terms of like how I switched to electrical engineer. I started with computer engineering.
Really?
Then, yeah, I took a microprocessor class, and that just exhausted me. And I was like, after this, I don't want to do anything with programming, and I'm done. And we actually went to the same school, so
Yeah.
we shared the same professors.
Yep.
That was Dr. Zhang. After working with him, I was like, this is it. I think I've hit the limit.
Yeah, I think I've hit the limit. Also,
Yeah.
when you look at the classes that you have to take for computer engineering and electrical, where it's like, okay, if you're a computer engineering major, this is compulsory.
Right.
But then you know you don't want to take that class.
Right.
You know you're going to hate it. So you just avoid the major.
Yeah. So.
But then we ended up on the right side. So good job to us.
That's now coming to the workforce, right? So now you've done all the school. The school was fun, right? Everything was good. You copied all your homework from your friends. It's because-
Yeah, right.
Yeah, I know you didn't do it. I'm joking. How do you see, like, what's the difference now you're in the workforce, right? Compared to how the homework or the school curriculum was, compared to now you're working full time, and the type of work. Is it one-to-one transferable skills, or do you feel like there's so many things that are different right now?
I think there are things that I picked up from college that transferred over, especially given the classes that I took, because my breadth electives were both in power, so 411, 412,
Yeah.
which were power inclined classes. So it fell in line properly for me.
Yeah.
Like that was a good decision on my part. Things that are different, it's like, well, in college, you know, you're looking at it like if you don't turn in this homework on time, or if you're starting to slack, your professors kind of cuddle you and it's like, okay, it's fine, you can come talk to me, or they want to push you to continue. Here, as much as you might be looking for that support when you first start, you're also grown up now, you're in the workforce. Nobody is going to beg you to do your job.
Right.
Like you have to do what you were signed up to do. You know?
Right.
Deadlines are also something that I took from college. Of course, chasing that 11:59
Yeah.
is, we all know how that is.
Right.
But then bringing it here, it's like these deadlines can change at any minute. And it's like, well, how ready were you before that? Were you, you know, pushing off to the side, like it's fine, it's not due until like 2 weeks. But then you could have started something if you could to help out, if that
Right.
makes sense.
Right.
So things like that transferred, but then at the same time, there's things that I've learned on the job, like asking questions. I didn't really want to ask questions in college, or if you do ask questions, you're like, well, it's something new that I'm learning, so I can ask as many things as I want. Whereas here, you kind of second guess, like, do they expect me to know this? So should I ask this so I don't look like I don't know anything, you know?
Right. You can always ask questions.
Yeah, I've learned that. I've learned here. I asked so many questions that I start feeling bad. It's like, okay, let's go ask somebody else. Let's give this person a breather.
Yeah.
That's how much it's been built into me now to
Right.
just ask as much as you want, because they don't expect you to know this.
To know, yeah.
Yeah.
And I mean, people are here to help you, and you know, like you have a lot of deadlines and other projects, so it's not like school. Okay, you're dealing with one assignment that you can focus on that, and you can do all the Google and all the ChatGPT you can and get your right answer. But with the workforce, you know, like you have people you're working with, and people are always willing to help, and you know, and nobody's expecting you to know everything. Yeah,
Yeah.
there's some things that you need to know, and there's some things that you'll just learn as you go.
Yeah.
Now, with that, how do you feel like when you came to the workforce, right? How much knowledge did you feel like you had from the courses that you took? Like, was there stuff that you wish that I wish I can go back and relearn it, or I wish they could have taught us this back in college, because it's just two different things.
Not really.
Okay.
And I think it's because of when I took my classes and when I started.
Yeah.
So everything was fresh in my head when I started, because I took 412 in the spring
Yeah.
and then I graduated in May. So
That's the power system class,
yeah,
right?
that's the power system.
I
So it
remember.
made sense for it to still be in my head
Yeah.
coming in. So not as much in that sense. However, there are, you know how it is with like certain classes that you take and you're like, okay, well, I don't really care about this class. I just need to get through it.
Yeah.
One time out, I'm done. I don't need any knowledge from
You
that
had those
class.
classes? I never had those classes. I only
I
had
bet you
classes.
did.
I only had classes that I wanted to take.
Yeah, no, there
I
were
was
some
such a good
classes.
student,
There were some classes
but I didn't show up in
that
classes.
there were some classes that I took where I just asked myself, like, do we really need to know this? But now you realize, like, you didn't know everything, but the principles behind them are what makes the job what it is.
If you were the president, yeah, and you had the power to change the education system, would you say that some classes should be removed?
Yes.
How many classes so far? Just give me a rough number from the engineering curriculum.
Oh, from the engineering curriculum.
Oh well, electrical engineering. Let's say that. The one that you said you felt like, why am I taking this?
Well, the thing is, I don't think it should be removed. I just didn't want to take it.
So
But the ones I wanted to remove
you should
are
be removed, not the
Yeah, I should be removed, not the class. Yes, the ones I do want to remove are the Go classes, just because they.
No, I have that same feeling, right?
Yeah.
Like when there's some classes when I was taking, and it's not because it's not a good class. It's just because of how much stuff that I have.
Yeah, and
it
they're
feels
also
like
difficult.
But in reality, when I look back now, some of those classes I take it for fun, right? Because I was like this elective, even the elective classes. Like right now, I'm a big fan of history, And when I was taking like those as electives, I was like, what the heck? Why am I? Because I felt like it was the easiest thing to do. But now I look back, it's like it's actually one of the most important classes
Yeah,
that
that's
I
how I
should have.
feel about anthropology because I took it as an elective.
Yeah.
It's
So
like, yeah, I've heard it's an easy A, but now that I don't have to take it for school reasons, everything is making sense to
Right.
me, and I
the
see it every day.
motivation is
So,
different,
yeah,
and that's the key in life, right? So when you know why you're doing what you're doing, you don't need anything to push you. You already
Yeah.
have the self motivation
it's
to push
self-driven. You
yourself.
have the zeal for it.
And this translates in everything in life, even at work. So when you know why you're doing what you're doing, right? When you're doing those power system analysis, when you think about it on a deeper level, then you have the energy to do what you need to do. Nobody needs to tell you to do it, right? So keep that in mind every time. That's my experience when I started trying to find the purpose why I'm doing what I'm doing, compared to like just meeting the deadlines. Because meeting the deadlines is one thing, but knowing why am I doing it for always gives me the energy.
Yeah,
Like
to
that.
keep going.
That's more that boost. So I've been here for almost 5 years, and
You're
that would
old.
be my advice to anybody who's coming in. Like, just always try to find the purpose why you're doing it.
Yeah.
Then you'll find the energy to do it.
So, can I ask a question?
Always.
Yeah.
It
so I
depends
just-
with what question you're asking.
It's a nice question, I promise.
Okay, and how much I'm charging. But today's free. Let's go.
I just want to know a little bit about like you and how you see the future. Like, what's a moment in your career that just made you feel like the future was here?
Like I said before, like the way I started engineering was mostly just from childhood problem. Like, we had a power outage all the time, right? So I decided to join to pursue engineering to solve that problem. I know it was a big problem, but now looking back at where we at 2025 and seeing that problem has already been somewhat solved. Like, there's not as much power rationing in where the hometown I grew up, but as back then, I feel like that, it just shows me like the future is already here. The little boy that was dreaming is already living in the future.
Yeah.
And that's me right now, And now not only that I'm living the dream, but also I'm part of that dream with everything that I do every day. So my work every day is contributing to that future that I had.
Yeah.
So that's how I know like the future is already here.
That was amazing.
Yeah.
Thank you.
All right, Viola. So you've been here for about approximately 4 months, right? As a new engineer. What would you advise kids or students who are graduating or who are about to graduate about engineering or pursuing the degree, or what's the future looking like?
I would say to just push through it. Like, there is indeed light at the end of that tunnel. And when you do see that light, you need to take it very serious.
Right.
Schedule is your lifeline.
Right.
Like, nobody jokes with schedule. Your time is your money. And so if you feel like you're overwhelmed in any way and you need more help, always reach out. There's people who are happy to help you, and they're happy to see that you have these questions and you're eager to learn.
Right.
Like, most of the nectar points that I've gotten here are off of you ask a lot of questions. It's like, okay, thank you for recognizing that, because I want to know more so that I reduce
What
the
are
number of
nectar
questions.
points?
Nectar points are a nice way of saying, hey, we see you, we appreciate you, and you're doing a great job at EVS. And each person gets about 50 a month, and we get to distribute it however we like. I've been so fortunate to have so many from a lot of amazing engineers, PEs, which is mind-blowing to me that people of that level like what I do and appreciate me that much. So it makes me really happy.
Viola, thank you so much for being here.
Yeah, of
Thanks
course.
for
Thank you
being
for
on
having
the
me.
pod.
Just for the listeners, give us an introduction of who you are, and yeah.
Sure. So my name is Curtis Hance. I'm a studies engineer here at EVS. So I work in the same department as like Wallin normally would. I've been here since, I think June 2024. So it's been about a year and a half as a date of recording.
Oh, wow.
Yeah, it's been a great year and a half so far. I'm excited to learn more. So I went to school here in Minnesota, University of Minnesota, Twin Cities.
Awesome. And what did you study in college?
Electrical engineering.
Okay. How did you find like for me when I was trying to figure out what I was going to do, I wasn't sure if I should do electrical or chemical, and it was just and then somehow I just said, okay, let's just do electrical. My uncle did electrical engineer. I was like, okay, maybe it's in the genes or something, and I just chose electrical. What was your choice? Like, how did you come to that choice?
I mean, it's funny that you mentioned chemical engineering because I also considered that one in high school. I knew I wanted to do engineering.
Uh-huh.
Math and science were fun to me, so engineering seemed like the natural choice. But as for the exact discipline, it's pretty arbitrary, honestly. Electrical sounded interesting. Chemical sounded hard. I didn't want to do chemical because chemistry was kind of hard.
Mm-hmm.
So I just kind of ran with electrical. We had a few family friends actually growing up that were electrical engineers, so I'll probably blame them.
Blame them, yeah.
Yeah, but I think it was mostly arbitrary. I could see a future, honestly, where I went mechanical instead of electrical just because that's what I was feeling that day.
Mm-hmm. Nice. No, it's funny that you mentioned that. That's kind of how I picked electrical as well. But within electrical, did you get to do a master, like a major in power systems, or because that's kind of what you do right now at EVS, right? Like you do a lot of modeling and SimCap and all that kind of stuff. Like, how did you? Is that something you studied in school, or?
Yeah, a little bit. So the way it works at the U is you don't pick an emphasis more so, but they have a couple buckets that each classes fall into. So they have buckets that are like power systems. There's one that's for like optics. There's one for like signal processing.
I hate signal processing.
I loved signal processing in
Oh,
school.
wow.
That would have been my second choice if it wasn't power. So you had to take like a broad variety of classes, but from one of those categories, you had to take multiple classes.
Okay.
So you didn't really emphasize in one topic more so than others, but you did have to take like a more depth into one.
Okay.
So that's what I did at school. I took a depth into power. So
Okay.
my senior year, I took power systems, power electronics, motors and engines, that kind of stuff.
Okay.
So I guess I emphasized in power, but there's no like official word of that on like my diploma or anything.
Okay. Like even at a event that I went to recently at a university, it's crazy how power system engineers, there's a dearth for power system engineers in the industry right now. And electrical engineering is like high demand, but within electrical, power systems itself is even higher of a demand. So it's a very niche topic that not a lot of people get into. And even when I was in school and I was a teaching assistant, like the professor used to tell me, hey, just give these kids grades. I want more people to come back to this course. So it's cool that you at least did power systems and you kind of stuck with it. So
It's a very interesting topic. It's very engineering focused, I found.
Right.
We talked about signal processing and like optics. Signal processing is very math focused.
Right.
I really like math to like that.
it's heavy math, yeah.
And optics is like very physics based. But signal processing power to me is a very engineering focused. A lot of problems that you have to have creative thinking to solve. A lot of going back to basics of like, okay, what did I learn in like electrical engineering 101? And just like applying that to a larger scale. So it's a very engineering focused discipline to me, and I really like that. I like a mix of both.
Very cool. So, can you give us a summary of what you do at EVS, like from the studies perspective? Like, what are some of the studies that you do and perform and stuff like that?
Sure. For studies, we work pretty closely with your team, actually, the design team. We help and support the design team. The way I always describe it to like my family or friends who may not be as in the know in engineering is that we help test the designs. We make sure the designs work properly, make sure they function, and if something goes wrong, we make sure that the whole plant doesn't blow up. So, for example, one of the most common studies we do is a short circuit study. We take your designs, we model it in software, and then we test if something goes wrong, if like a line touches the ground and there's a fault and current rushes all to one spot. We check to make sure that the cables are not going to melt, like literally melt from the heat that they're experiencing from all the current that's rushing that spot.
Yeah.
We make sure that all the equipment that you're using in the site is rated for that much current. They're also not going to melt. We also check to make sure that when design team provides us with a layout, we want to make sure that you have spaced cables properly, right? Making sure that they're not going to overheat each other from being too close to each other, because we want to maximize how much current we're putting on those without reaching temperature limits.
It's almost like everything comes back to thermals, right? Like
it is kind of crazy how much like thermal is like important, because that is like the cables melting is a big problem that we need to make sure it does not happen.
Yeah,
because that would be disastrous. And so there's a whole range of studies. There's a lot of them, more than just the couple that I talked about. But those are the there's like 4 main ones that we do. So there's those 2. There's one where we make sure that the plant is providing enough power. Like if we're saying that this plant can provide 100 megawatts, well, we need to do a study to make sure it's actually providing 100 megawatts and that it's capable of doing that. And then it's also capable of producing enough reactive power. So imaginary power.
I know it's crazy that it's only 1 year. I don't know. I feel like I've been working with you on a lot of these best projects that we're doing together. Especially it's hard ones. I think when you joined, you just got into best for whatever reason. But anyways, yeah, it's been a year, right? What's your highlight for this? Like for the year that at EBS? Like, is there any highlights? Any challenges that you want to talk about?
Oh, there have been tons of highlights. Definitely a highlight though has been learning. A lot of opportunities to learn here at EVS, a lot of opportunities to take on challenges and kind of make yourself uncomfortable in order to better yourself, to learn new things and expand your horizons.
And also, final question for you. Who's your favorite design engineer? Not me.
I'm going to plead the fifth on that one. So, Prahlad, I actually have a question for you. Solar is a very new industry, constantly changing, especially with BESS. BESS is very new, and I feel like over the course of a year, even I've noticed that things are constantly changing.
Yep.
And a common answer is that, well, we haven't worked that out in industry yet. We're still figuring it out. In that context, what do you think in the next 10 to 20 years, the biggest challenge that this industry is going to face?
I think biggest challenge, there's 2 challenges. I know there's an active challenge right now, which I kind of highlighted earlier, which was the dearth of power system engineers, right? There is a crazy demand right now for that's on the grid, that's coming onto the grid through data centers, EVs, and just general electrification, right? So with this demand coming in and supply not being able to meet that demand, there's a lot more need to kind of power these things. And so most folks are trying to look at renewables as the option to help power the grid and power these sources. But I think that the first challenge there is when you are interconnecting so much renewables onto the grid and so much of intermittent sources onto the grid, like how does that all work together? And so right now I know there is a dearth for power system engineers, and so I think that would be the biggest challenge is can we find engineers to help solve this problem? So that's one of the big challenges, and that kind of got highlighted when I did go to that university, and the professors were talking about it. That hey, we need power system engineers, like, and that is one big challenge in the industry. The second one I think is going to be just policy. Like I always think policy kind of dictates, like, and it kind of enables the technology to be deployed. And so if there's lot of changing policies or policies that are not favorable for renewables, that could start to affect the industry. And so trying to have like good policy that can help solve this demand supply problem is something that has to get worked out. So it's a combination of, from the engineering side, I think we need more power system engineers, we need more solutions to kind of make sure that this demand supply problem gets solved, and then the second is the policy to help with that.
Interesting. I find that very interesting that there is a lack of power engineers, especially for renewables. I feel like a lot of younger engineers would jump at the bit to be a renewable engineer, to work towards a renewable
I think that
future.
trend is starting to happen now. I think even when I did some interviews with recent grads, a lot of them are coming with renewable experience. Like I didn't get a chance to do renewables when I was in school. Like that was not a topic. Like even when I did power systems, it was very, hey, like it's very academic. It's not gonna focus on one industry, or renewables is intermittent. It's again very academic in that sense. But now kids are coming in with a lot of renewable experience, and I'm looking at their profile. I'm like, I'm jealous. I'm like, shit, I wish I got this opportunity to do that at school. Any advice for any young professional who wants to join this industry? Any words of wisdom?
I would say take any opportunity you can to learn. It is crazy to me how much you learn in college, and then you come out of college and start working, and you realize you know pretty much nothing.
Yeah.
That you are back to being like a little worm compared to all these people who have been in industry for 20, 25, 30 years. So savor the opportunity to learn.
Yeah.
It's a very valuable experience, but at the same time, don't let it get to you that like you don't feel like maybe you're like one of the smarter ones in class anymore. you've got your entire life to work, to learn. You could work in this industry for your entire life and still learn something new every day.
Yeah.
So there's always more to learn. And the more experience you have, the better.
Yeah. Awesome, Curtis. I think I enjoyed this conversation with you. I know we chat regularly on project stuff, but it was nice to have you on the podcast here.
Hello, I'm Sheridan Henderson, and I'm here interviewing. Who are you?
I'm Sam Zapata. I'm a civil engineering associate, and I've been here for almost a year.
So, kind of, what's your backstory of how you got into engineering in the first place?
Well, I feel like I've been surrounded by engineers my whole life, especially on my dad's side. He's an electrical engineer and has been working as an electrical engineer for almost 30 years now.
Mhm.
So I knew I wanted to do something related to numbers and math. I also liked chemistry a lot. So I knew I wanted something related to science. And I realized engineering was the field where I was going to be able to actually use science to my advantage to make people's lives better.
And also
So,
math.
Exactly.
That's just the basis of it.
Yep.
Did you realize this in high school like I did?
Yeah.
Yeah.
It was like a long time ago. I was probably first year of high school, honestly, probably my freshman year. I was like, all right, I know what I want to do. And it never changed.
Yeah. So you're from Columbia.
Right.
So what was the path into engineering looking like going into school in Columbia and then transitioning into college?
Right. So, like I said, I always knew I wanted to do something related to science, related to engineering. So, when I was in my last year of high school, I actually came to the US for a tennis showcase. I've been playing tennis since I was 7 years old.
Really?
Yeah. So, I knew I wanted to be able to combine those two passions that were science and sports. So, I got recruited. I ended up going to a school in Pennsylvania, and then I knew I wanted to focus more on academics, so I ended up transferring to the University of Wisconsin-Stevens Point, and that's where I got my bachelor's. It also had an emphasis on sustainable energy, so I knew I wanted to do something within the renewables field, and that's how I ended up here.
I was going to say, perfect place to work
Yep.
after that.
All right.
Was renewables an option at the University of Wisconsin, Stevens Point that you went to? Was there kind of a set renewables emphasis? Because it's such a new industry. Were there classes available, or what was the path going into that?
Right. I actually took a lot of classes in renewables. It was mostly focused on solar, but it was mostly on the electrical side of things. So my minor was in renewable energy, mostly focused on solar, not so much on civil, which was a little different when I came here because it's so site specific, it's more niche, but I already had the basics, So it was not too hard to actually get into that field. I feel like I made a lot of connections as well. So it made it somewhat easy for me to get to the point where I am right now. So are there any specific breakthroughs in solar energy efficiency that you're mostly excited about?
Actually, in one of our previous episodes, we talked about agrovoltaics, which is kind of a newer technology which basically combines farmland and agriculture with solar. And so these solar panels are now being placed on farmland that can be used for growing different types of crops that might survive even better under shade. So I'm excited about agrovoltaics too, because one of the complaints about the solar industry is that they're taking up all the land, they're taking up all this fertile farmland, when this could be a new technology that will help kind of combine the two and still make use of the land for agriculture and also generate energy. So that's something I'm very excited and still learning about. And hopefully we'll talk about more in a future episode. Well, Sam, thank you for joining me and helping me learn more about your background and what you like about EVS. And we will now switch to the next emerging engineer.
All right, we're back with the next part of the Emerging Engineers episode, and I'm sat here with none other than...
Suhil Singh. So I'm in the physical team in the substation department, working as an engineering associate 1. I've been here for 5 months now. And
Only 5 months?
Yeah.
You're one of these people that it seems like you've been here for like 5 years. Like I can't remember a time when you didn't work at EVS.
It went by super fast
Yeah.
for me.
Yeah.
And it's surprising.
There you
But
go.
I learned a lot in these 5 months. And more about me, I was in Idaho, University of Idaho for the last 4 years, graduated with an electrical engineering undergrad. And I had 2 internships before coming here. One was at SEL, Schweitzer Engineering Laboratories. They make protective relays. That was a good experience. And then the second one was last summer at a utility company in Idaho. It's called Idaho Power. That was also a great experience, and this is my first job out of university.
Wham bam.
Yeah.
All of that in very good summary. So where did you grow up? Where are you from?
So I was born and grew up in India.
Mm-hmm.
I was there till I was 18.
What part of India?
It's a state called Punjab. It's in the northwest region
Oh,
of India.
okay.
So it's really flat, a lot of farming land there,
Mm-hmm.
and doesn't snow there. That's a big thing.
It doesn't snow.
It doesn't snow there.
I mean, where does it snow in India? There are mountains, right?
Oh yeah.
Yeah.
The Himalayas,
Yeah. Oh, yeah. No big deal.
the biggest one.
I thought that was like more Nepal. That's in India also,
the mountain range starts in.
and it's in China too, I guess.
Yeah, it's
Yeah.
a big mountain
I'm not
range.
from
It's
there. I
multiple
don't know.
countries. Yeah. But it does snow in some areas, but mostly it doesn't snow. You're right.
Okay.
And so I was there till I was 18. Came to the U.S. as an international student to University of Idaho.
What prompted you to want to go international for school?
You know, I think education, the university level education in the U.S. is really great, and you have so many opportunities after that to grow and learn, and actually like working in a company that is doing something. Like we're making substations, we make PV and BESS yards, and
Sure.
that's such exciting work.
Yeah.
And I feel like the US really provides that.
Yeah.
So that was a big pull.
Awesome. Okay. So you went to Idaho.
Yeah.
And then you did 4 years there.
Mm-hmm.
And then now you're here. Okay, so now you've been at EVS for 5 months.
Mm-hmm.
You're working in physical substation.
Yes.
As opposed to what? Like imaginary or something?
No, there's multiple teams in the substation department. So there's physical, there's structural. We have our own structural.
I did know that.
Yeah.
Yeah.
And then there's PNC, that's
Yep.
protection and control. They do all the relay work
Yep.
in a substation. And then we have SCADA.
SCADA, shout out Jason.
Yep,
He's
yep.
Jason's been on. I know Jason's watching right now.
Yeah, he's one of my favorite people at the company.
I know. Same. He
Yeah.
just kind of like slid right in there. He was hosting the Monday meeting like
yeah.
a couple weeks ago.
Yeah.
That is like a rare honor. I've never hosted the Monday meeting.
Everyone
No one's
loves
asked
him.
me. Jason's just like, yeah, I'll do it, whatever.
Yeah, he's
so
really smooth.
good for him. Okay, so yeah, SCADA, PNC,
SCADA,
etc. What else?
We have a design team. So us as the engineers, we have an idea of what we want in a substation. We edit PDFs, that sort of work. But the designing team is they do the actual CAD work. So they make the drawings look beautiful. They make
Yeah.
it look coherent.
And your drawing sets are like 1,000 pages or something, right? Am I off
Ye-
base here?
Depends on which team you're talking about.
Yeah.
For the physical team, there's if you're talking about there's different packages.
Yeah.
30%, 60%, 90% IFC. If you're talking about IFC, the final one, there's on the physical team, there's probably like 35, 40 drawings.
Okay.
Structural has
Normal.
more than that.
Okay.
And then PNC, they have a lot of drawings. They have hundreds of drawings.
And so you're not dabbling in the PNC drawing world. Like,
Thankfully.
okay. I just have heard these tales like they have like 1,000-page submittals, and it's like, how do you look at all that? But
I bet the PNC does.
yeah, they've got a
have
very
lot
talented
of
team.
drawings.
That's how they do it.
They do. They do. Yeah.
So when you were exiting school, I mean, what was your degree in also?
Electrical engineering.
Okay, electrical engineering. Did you have an idea of like what you wanted to do then versus what you're doing now?
Like while I was
Yeah. Did you want to
degree,
be a physical substation engineer?
I had no idea this
Yeah.
niche existed.
Yeah. Most people don't. I mean, yeah, once you get into
Yeah.
industry, like I would have never thought like, oh, I'm going to design solar piles, with that education I got. And then one thing I always love to point out is like we design fence posts.
Okay.
Like we design fence posts. Like would you think that a fence post needs like, someone with a professional engineering
Right.
stamp and a master's and 15 years of hard-fought experience to design?
You don't even like if you're not in the industry, you don't even think about these things. Like,
No.
I do one thing that's called illumination study.
Yeah.
So that's basically how much light do you have in a substation.
Yeah.
That's it. Like
What do you mean, like?
You do a whole study just how much light do you have? There's nothing engineering about it.
Like shining onto the substation?
Yeah,
Like
'cause-
literally like just sunlight?
No. So lights like light
Yeah.
fixtures.
Oh, sure. Yeah.
So you need to do a whole study on how many how much luminosity do you have, the foot candle levels. So that's a recommended.
Someone needs to design that.
Yeah.
You can't just go to Home Depot and just buy a bunch of lights, string up some like rope lights.
You have to meet some requirements.
Yeah, you could do that. It might be a good vibe, like if you had like party lights. But
Just LED lights. Yeah.
have you experimented with, in your illumination studies, having dimmable LED lights, or like you could have red or blue or rainbow?
I think there's a standard color that's probably white.
Okay,
It's
fine.
just white. Yeah.
All right,
People have
fine.
to work there.
Yeah, that's a
Yeah.
good point. So what would you say are some things that, other things that you like didn't know would go into a design or something like this? Like when you're exiting school, you're like, oh, what am I going to be when I grow up? And now you're doing illumination studies. Like, what are some other things that are unexpected tools of the trade?
A lot of things. So going back to university, it trains you for a broad, like electrical engineering is a broad field. You
Yeah.
have to study a lot of things. Like
Yeah.
there's signals and systems, electromagnetics, energy systems, microcontrollers.
Yeah. Did you have a favorite subject? You mentioned electromagnets. I'm like, magnets are cool.
Electromagnetics was fun.
Yeah.
I really liked microcontrollers, but that was also my worst grade.
Yeah. Yeah.
That's a
Do that
different
one
story.
for fun on the side.
Yeah.
Yeah.
That was a fun class.
Yeah.
But no, there's so many new things when you enter the industry that you're not taught in university. The university prepares you for the basics. It tells you what voltage, current is, how do you manipulate them, how do you control them, how do you measure them. But when you come into the industry, you realize there's so many more things. Like one thing is when you're building a substation, depending on the voltage level, you have to keep a certain distance between equipment. So like the bus supports have to be a certain distance from the transformer, the CVT, SST.
Is that so things don't like short out?
Yeah,
or,
yeah.
Or blow
could be
up.
deadly.
Yeah. Don't blow up the transformer, probably.
Yeah. And then there's a lot of equipment that you never hear of during your degree.
Oh, totally. Yeah. Yeah.
And then there's grounding studies, conduits. How do you run the cables or the conductors underground? There's pull calculations. So that's how much angle you can have on a conductor that's being pulled. You have to get the cables from an equipment to the substation house, the building.
Yeah.
So there's a lot of things.
So many things,
Yeah.
right? Yeah. So many things. I like going back to my fence post comment. Like I would never thought, right? Or that solar piles, like in the structural group, like would be as complex as they are. Because you think it's just like, oh, it's just like a driven piece of steel in the ground. Like,
Yeah.
how complex is that? But then you see the tool we have to work with, and it's like a marvel of Excel engineering. It's like incredible.
I have a question for you now.
On what subject?
It has to do with PV and BESS, but I know you're structural. So
Okay, all right,
you
fair
can
enough. Here we
answer
go.
from that perspective.
Yeah, okay.
So the question is, in 30 years, how do you think the PV and BESS design, the way we design PV and BESS right now, would change or
Be different.
yeah.
From a structural perspective, I think more efficient materials, more efficient installation methods, things like that. I mean, we use driven steel piles right now, so that's one thing, and we use standard shapes and sections. So these are like, in short summary, these are from like a standard library that's regulated by a governing body. It's the American Institute of Steel Construction. These are like the shapes that they specify, so that if you get this shape from one fabricator, it's more or less the same as from another one. So we do that, but something we're seeing now in industry with some fabricators is they have different methodologies. But now we're seeing in industry, there's a methodology that basically they can take 3 coils or plates and basically weld them effectively together as an I section. So what does this do? Basically, it allows you to custom engineer your shapes, your steel piles, for your site characteristics and the engineering demands. So like our game in structural is basically cost optimization. So we're trying to like have the steel be like 100% utilized at the maximum design scenario. So I think like looking forward, we'll probably see like materials being utilized that are custom engineered for the site applications, and then basically as designed to be the lightest that they possibly can. Other things, like I'm hoping there's technologies that will solve the ad freeze problem. So what is ad freeze? Ad freeze is like if you have something, a pile driven into the ground in Minnesota, well, in January, the ground freezes. And when the ground freezes, it grabs onto whatever, your steel pile, and it tries to push it up. So it's like a frost jacking force. So we have to design for that. So our piles are embedded longer so that the soil that's not frozen resists that force. So like we have piles that are, 5-10 feet longer potentially than we do in southern climates with no frost.
Yeah.
So stuff like that'll help. I think lighter materials and better use of them, and more efficient installation methods.
Well, there you have it.
That's my.
You heard first it on
That's
Sounds
my
of Solar.
Yeah, we'll see. Yeah. Whoever patents some of those, I think, will make a lot of money.
Yeah.
So I should get on that pretty soon. Couple more questions for you. Same kind of thing, maybe for your own personal life. Looking forward, what's next? Like, what are you thinking about for? You only started working 5 months ago, so maybe it's an unfair question. You're trying to settle in, but like, what are you excited about moving forward in Substation at EVS?
So there's a lot of. So I've been here for 5 months, and I feel like I haven't utilized my electrical engineering degree to the most yet. So I'd like to do some cross trainings or sit down with some people in studies and learn how they do their studies, the grounding studies. There's so many other studies they do.
Yeah.
And
so you're interested in that aspect, not necessarily the physical design?
Physical is also very interesting. I would like to stay here and learn more about that, because if you design a substation, that's so cool. But I think the studies folk, they do a lot of electrical engineering, and I'd also like to learn a lot of that stuff.
Okay. That's good short-term, plan and long-term plan, right? Well, I've never been out of things to learn here, so I think you'll be fine there. So closing out, if you had to give some advice to someone in your position, 5 months ago, entering industry, what would that be?
So when you graduate from university, you think that you know everything now, and once you enter the industry, you're going to be productive. You're going to know how to do everything the first day you're at your job. It's not like that.
Yeah, it's the opposite of that.
It's the opposite. You're like, what did I do the last 4 years? I know nothing about what I'm doing here. So ask questions. Like everyone knows you're brand new here, and they expect you to ask a lot of questions. They don't expect that you should be answering their questions, or you should have the answers to all the problems they have in their designs. So ask questions. You're here for learning in your first few months, and then slowly you can start contributing.
Wham bam, there you have it. All right, we're going to send it back to the other hosts, close it out. Thank you, Suhil, for joining me today on the Sounds of Solar podcast.
Thank you.
All right, so we just finished hearing from all these young emerging engineers. What sort of takeaways did you have? What did you think about Sam Zapato?
Sam was great to talk to.
Of course he is.
I know. Very good conversationalist. I would say a good takeaway is just how growing the renewables industry is getting within colleges. I remember when I graduated, it was just kind of, here's like maybe one informational class about solar. There's not really any technical classes offered. When I talked to him, I found out that he basically took an entire semester of courses that went through actual solar design and calculations, and really got into more detail with it. So I think that's
What?
Yeah. So it's cool to learn about that. It's really expanding within education.
No, I agree. I think I want to echo everything that she said there. Like, it's a lot of the kids that I'm interviewing now these days, they all come with renewable experience.
I suppose you're old enough to call them kids.
Maybe.
Just barely.
That's a good point. No, but they're coming with renewable experience, and I was so jealous of some of them. I'm like, wow, these guys have these courses now. They can go and learn these. So it's pretty cool to see that. And for me, Curtis, I think he was very balanced, very, and I feel like for somebody just coming in, I don't think I would have been able to do that. Be able to come on a podcast, just be balanced and kind of talk with that maturity. So I think kudos to Curtis there. So,
Amazing.
but yeah.
Yeah, to echo what you guys said, actually, I did a career fair in Madison, Wisconsin, and most of those students there, they had experience with solar classes, and I was like, where was this when I was going to school, right? So I learned everything about solar while working.
Yeah.
So that was good to see. But also, I was talking to Viola and just connecting with her. We went to the same school as well, and we
you did?
Yeah, so we kind of had the same path in terms of career. She started with computer engineering, and then she switched to electrical, and I had the same route too.
I did not know that.
Yeah, we didn't want to do more programming. So just talking to her, like, it took me back to where I was in terms of like how I was thinking and how I was a little bit intimidated of how the industry is going to be. Like, am I able to do all these, right? But at the same time, all the classes that she took or I took was also preparing us for this, like with the timeline, with the things just changing every time, being able to adjust on all this. So hearing from her was like, something encouraging to me.
Yeah.
Yeah.
What about you, sir?
Well, yeah, Suhil and I had a good sit down, and I mean, I know Suhil before. He's so tight. He's so cool. So that was awesome. But yeah, I think like big takeaway was remembering that period of time, like we were talking about earlier, just like how, when you leave school and you think like, oh yeah, I know some things. I know some things. I'm gonna come in there and do stuff. And when you start, you don't know anything. Like it sucks. Like you're just like, especially in this field, like no one went to school for like anything we do. Well, it sounds like actually Sam had one class. So
yeah, there's
so
a
there
little
you
bit
go.
of intro
So
there,
he did
but...
know stuff. But like, just relating that and like, when I graduated, I thought I was going to design commercial buildings and that was it, or whatever, something similar to that. But solar piles are not quite the same, and never would think that those would ever have any design needed really in general. So yeah, that was cool to just kind of touch on that. But
and you do see some parallels too between what you learned and what you do here.
Right.
There's some parallels in what we learn how to design in school.
I mean,
But
the foundation is there, but
Yeah.
but I
that's
don't know.
a structural pun.
Yeah, I guess.
You got it.
But no, but foundation is there. But I feel like it's just even when we talk about voltage and current and all these things, I always felt I knew it, and then like I still remember first day on the job, they're like measure it. I was like, dude, this is scary.
What do you mean?
What do you mean?
Where are my
Like
notes?
how?
Yeah, where are my notes? Where's that textbook that I was referencing?
Oh, yeah.
You had to pay $200 for.
Yeah.
Yeah.
Do they have textbooks anymore, or is that
It's all PDF now. I
PDFs?
guess.
Yeah.
Yeah. All right. Well, I think that's going to do it for us today on the Sounds of Solar podcast. Do the thing, hit the button, like, share, forward it to your neighbor.
Comments.
Give us a nice comment.
Yeah, comments would be good. Like good, constructive comments. Let's try that. So we'll see you next time on the Sounds of Solar podcast.
Ciao.